Bom tarde a todos. And thank you very much for organizing this conference and for everyone who's worked very hard to put this together. I know these things are not easy. This has been a wonderful 2 days for me. Yesterday, I think the problem of resistance in arboviral vectors was extremely well defined. And today, I've seen a lot of hope for the future. So I'm happy to be here. And I'm especially happy to be here because I've got some very good news for us. What you're looking at here is an aircraft applying a fine drop spray of BTI strain AM6552 over the Wynwood neighborhood in Miami, Florida this year. This spraying was done as part of a CDC and Miami-Dade County plan to intervene in the Zika outbreak that was occurring in Miami-Dade. It was an integrated program that involved adulticides and BTI as a larvicide, and it also involved a number of interventions in terms of taking care of source reduction and other things. So it was a comprehensive program, and it was very successful. This is from Morbidity and Mortality Weekly Report, US CDC publication, September 23rd, 2016. And it states that during the period of June 30th to August 5th, 2016, the first recognized outbreak of mosquito-borne transmission of Zika virus in the continental United States occurred in a neighborhood in Miami-Dade County, Florida. 29 persons with Zika virus infected had likely exposure within an approximate 6-block area. The outbreak ended after aerial spraying to control mosquitoes. No increase in short-term health effects were associated with the spraying. So here we have an example of an integrated program using product that has intrinsic resistance management properties, and I'll tell you to achieve a positive health outcome. So what really happened here? Well, this image shows, with the dotted red line, a 10 square mile area surrounding the Wynwood neighborhood where the outbreak was occurring. Over that 10 square mile area, a mosquito adulticide, an organophosphate mosquito adulticide, was applied. And when that mosquito adulticide was applied, the BG sentinel traps which were set throughout that area, populations would go down. They would go down temporarily and they would bounce back up. So the decision was made over this 2 square mile area that covered the outbreak to apply BTI strain AM6552 in a fine drop spray in order to deliver the BTI to all the small containers on all the properties within the block. And these small drops were able to penetrate through the vegetation, reach small containers that were completely obstructed from the sky. And we had very good kills in sentinel jars that were placed throughout the area. And so after 4 of these sprayings, where we had both combination of larvicide and adulticide, the outbreak ended, and the governor of Florida declared Wynwood a Zika-free zone. So we're proud of this accomplishment, and I think it's a sign of hope for us all. So how did we get here? I mean, 40 years ago, in the Negev desert of Israel, Yoel Margalaith was sampling for mosquitoes. He found culex larvae in these residual pools along a riverbed that were dead and dying, and he asked, why? Why are these mosquitoes dying? So he worked with Goldberg and some other researchers to isolate what was happening here. And what they found was the common theme in all of this was a bacterium called Bacillus thruingiensis israelensis, and it was named serotype H14, or BTI. Today it's known as BTI strain AM6552, and this bacteria has been developed worldwide for use in public health mosquito control. Dr. Margalaith in 2003 earned the Tyler Prize for Environmental Achievement for his discovery. This prize is like a little Nobel Prize almost for environmental achievement, and it was stated when he was given the prize that his discovery in 1976 of the new microbial subspecies known as Bacillus thruingiensis israelensis, which is lethal to most species of mosquito and blackfly larvae, has had an enormous effect on human health and on environmental quality. So what is this BTI? Well, first of all, it's a gram-positive rod that produces 5 insecticidal crystal proteins. These insecticidal crystal proteins are essentially non-toxic until they're ingested and digested by mosquito larvae. It's toxic only to specific insects within Diptera nematocera, so it's a very narrow spectrum of insects. The genetics of the proteins that are involved in this were worked out by Ethan Bendov in 2014, and he presented a review paper on all of this. And the larvicidal activity resides in 4 major and at least 2 minor polypeptides encoded respectively on a single plasmid. So we've learned a lot about the bacterium and what it can do. We've also learned that in order to produce this bacterium and the protoxins effectively, we need to do this in industrial fermentation. And it's really as much of an art as it is a science to produce and express the proper ratio of these protoxins to achieve the result. And this is the ValentBioSciences plant, and we're very proud of the investment we've made. These are 100-liter fermenters, or 100,000-liter fermenters, so we produce in large quantities. So how does it work? Well, the insecticidal crystal proteins and the spores, when you apply the product to the water, are suspended in the water. Mosquitoes are filter feeders. They take in these, mosquito larvae are filter feeders. They take in these insecticidal crystal proteins. And when those insecticidal crystal proteins are exposed to the high pH and and specific enzymes that exist in the midgut, the proteins are cleaved into smaller components which will bind with the insect midgut, creating pores. And this interrupts homeostasis, and the mosquitoes just can't maintain homeostasis and feed, and they die. But the beauty of all this is that BTI has intrinsic resistance management. And what I mean by that is that the toxins are not just one toxin. There's this whole suite of toxins, but there's 2 toxins known as site toxins. The site toxins and the cryotoxins are all packaged with the bacterial spore when the spore is formed. So whenever a mosquito larvae takes this in, they get this whole suite of toxins. The site toxin is highly synergistic to the cryotoxins. And this is another quote from the article by Dr. Bendov, which says, despite the low toxicities of site 1A and site 2B alone against exposed larvae, they are highly synergistic to the cryotoxins, and hence their combinations prevent emergence of resistance in the targets. The lack of significant levels of resistance in field mosquito populations treated for decades with BTI bioinsecticides suggests that this bacterium will be an effective biocontrol agent for years to come. So, in 32 years of field use with BTI strain AM6552, there has been no resistance in the field. There's also no cross-resistance to any other active ingredients used in public health. And it's not used in agriculture, so there's no selection pressure towards resistance from agriculture. Nor is it used in urban pest management, so there's no selection pressure for resistance in the urban areas. So we really believe we have something that has its own resistance management, its intrinsic resistance management. But in addition to that, bacterial larvicides such as BTI and B. sphaericus also are highly target specific. They only affect mosquitoes, black flies, and closely related flies. Well, why is that important? That's important because we can spray this material over wide areas, kill mosquitoes, but not kill any beneficial insects, not harm anything else. So it's very beneficial to have this target specificity. It's also safe for humans. This is a publication from World Health Organization from the International Program on Chemical Safety, Environmental Health Criteria number 217. A thorough review of all the Bacillus thuringiensis insecticides. The important conclusion for us is that BTI is safe for use in aquatic environments, including drinking water reservoirs for the control of mosquito, black fly, and nuisance insect larvae. So it went through WUPI's review. BTI strain AM6552 was approved in the WUPI's process. As a bacterial larvicide, it's the first one to have gone through the WUPI's process. So All these attributes are great, but what does it do for us, and where's the proof? I mean, where's the proof that we're really impacting human health in a positive way? Well, I'm going to give you some case studies. We have a case study from Malaysia, one from Cambodia, and one from the Florida Keys. In Cambodia, a multi-year study was conducted, first to look at residual efficacy in these cement water jars that are typical in Cambodia, also to look at is it safe, and to see what we can do with treating multiple containers. What was found was there was extended residual control of 3 months in this type of container with a single direct application of Vectobac WG, the dry material directly applied with a small spoon to the containers. So with this knowledge and the knowledge that the area surrounding Phnom Penh had quite a lot of resistance to Temifos, the decision was made to remove Temifos from the program. And this created an opening, and in 6 districts surrounding Phnom Penh, the BTI strain AM6552 was routinely applied once every 3 months to these water jars, and in 5 other districts, it was not applied. And so in the 6 districts, there were 500 villages, 85,000 households, and in total 750,000 containers were treated. And again, this was direct application by hand. So here's what happened. This chart shows dengue cases by district recorded at health clinics, and the percent change in dengue cases reported at health clinics from 2010, the pre-treatment year, to 2011, the treatment year. These red bars show what happened in the untreated area. And we had increases in dengue cases as high as 700%, and some variance there. But in the treated areas, we had decreases generally across the board, and only in one district was there an increase, but it was immediately adjacent to the district with the 700% increase, and they shared health clinics. So there was some spillover there. So to sum this up, comparing the 6 untreated districts to the 6 treated districts to the 5 untreated districts, there was a 43% decrease in dengue in the clinics in the treated areas, but a 395% increase in dengue in the clinics in the untreated areas. Just let me back up. And this paper was just published September of this year in PLOS Neglected Tropical Diseases. Tosetha is the author. It's a good read. I recommend you look it up. Okay, that's fine. That's great. We're able to do this in big containers, and that's exciting. But we all know, and we've seen it 20 times in the last 48 hours, these 80s don't just develop in big containers anymore. We live in the age of plastics. There's water trapped everywhere, and it's hidden, and we can't find these things, and it's a tremendous amount of work to run around and look for all these things. So the solution we have is to use this spray application. Use small drops of a suspension of BTI to drift them into the containers. Let the drops find the containers. Don't spend all day trying to find containers. Let the drops find the containers. So these are just some examples from around the world of work that's been done. This lower left picture is from Malaysia. Lower right is from in Panama. Upper right is Recife, Brazil, in a cemetery. And upper left is Florida Keys mosquito control with an aerial application. I'm going to cover the case study on spray application from Malaysia. This is a very straightforward study, simply applying with backpacks to spray the product directed at targets of areas where containers were either known to be there or suspected of being there. And there were 2 zones. One was 10 hectares with 400 houses. The other was 8 hectares with about 300 houses. And the non-larvicide area is here on the top, BTI larvicide area on the bottom. What happened was in the non-larvicide, in the BTI larvicide area, 1 case of dengue occurred during the first month of spraying. During the course, this was a long project, almost a year of spraying. But in the non-larvicide treated area, 15 cases of dengue occurred. Each of those cases of dengue was responded to with a truck-mounted adulticide ULV spray. It had no impact on the dengue, and it had no impact on the population of Aedes aegypti that were being monitored. But the BTI spraying with backpacks suppressed dengue, and these two study areas were only maybe a mile and a half distant from each other, same exact conditions. So this is also published by Tan et al. In 2012 in the Southeast Asian Journal of Tropical Medicine and Public Health.
Can you please conclude?
What?
Can you please conclude within 2 minutes? 2
minutes?
Yes.
I think I can do it.
Please. Thank you. Thank you very much.
Okay, so I'm going to talk about BTI strain AM6552 aerial wide area spray. In 2009 to 2010, in Key West, Florida, there was an outbreak of dengue. There were 22 cases in 2009. This was followed by house inspections, source reduction, public education, and ULV mosquito adulticiding. In 2010, there were 65 cases of dengue with a stepped-up program of this nature. So the decision was made in late in 2010 to have a look at aerial application by helicopter of BTI strain AM6552, and the applications were done routinely throughout 2011. Since then, there have been 0 cases of dengue in Key West. The house inspections and public education have continued, but the ULV adulticiding was stopped. And another note here, Key West had a large number of imported Zika cases, but no local transmission of Zika with this routine being applied this year. So, mucho obrigado, and it's been a pleasure.